application in tables like this. Okay, so here you have rainbow of colors. Okay, here you have the internal materials that were used for that particular LED. Actually, there are some companies in which you specify the wavelength of the color that you want to get, and they are able to manufacture millions of LEDs exactly what that wavelength. So right now we are going to consider the super green LED since it is easier. So please consider that the BF voltage at 20 milliamps is 2.0 volts. So we will go back to the circuit. Now the activation voltage is 2 volts. For silicon it's 0.7. So now you are able to solve the rest of the problem.
Ya sé que no, ¿me lo puedes checar? Según yo es así. Es una línea nomás.
Puede ahorita trabajar, sería está bien.
Y pues comparten la misma corriente.
Pero para sacar la corriente con este casi 11.3, ahí sí te sale un poquito. Ah, no, sí, está bien.
Es nomás la resta.
Sí, está bien. Como que entra. Exacto, sí, está perfecto.
Y el de LED, pues.
O sea,
No van a venir.
¿no? No, pues ya me di cuenta.
Yo también.
Sí, yo creo que ya es una hora es más que suficiente.
Sí.
Second participation taken. So there will be one last chance to participate at the end of the class. So let's understand the basics. First of all, since these two diodes are connected in parallel and they have different activation voltages, when I say activation voltages, I am talking about BF. Okay, you remember this is the forward voltage. Okay, for silicon it is 0.7, for germanium it is 0.3. For an LED, we should consider what color is that diode. Okay, so in this case, this is 0.7 and this is 2 volts. Because you cannot have the same voltage, okay? What is the voltage? If I asked you what is the LED, what would you say?
0.
0? No.
I mean, sorry, 2
No.
2 volts, right? BF?
No. That's right. Again, please note that these two components share the same voltage. Even though this one is not on or is not
Oh.
conducting should have the same voltage. So since this one is working as a voltage source, then this voltage is going to be shared with the diode. So the diode is going to have 0.7 volts, and this voltage is not enough voltage to turn the LED on. So the LED will be off, but the voltage will be 0.7. This is very important. Now we know that, again, without writing any equation at all, you need to be able to tell me what is V0. How can we get V0 without writing any equation?
That's gonna be 12 minus.
12, again, same methodology. 12 minus this voltage, this is 0.7, and then you have reached V0. So V0 is going to be 11.3. Without writing any equation. Now what's next? So now that we know that ILED is 0, ISI and I2.2K are exactly the same. How can I get then that current? Well, I2.2K equals to ISI equals 11.3 divided by 2.2K. So ISI equals how much?
5.14 milliamps.
5.14 milliamps. Is that correct? Okay, so hopefully we are warming up, and then you are able to solve more complex exercises. So the next two exercises are just for practice, okay? And hopefully there is no need to write any equation at all. Well, first of all, I'm going to skip this part. This part is important, but I can skip it, okay? And I am going to move directly to multi-diode circuits like this. So I need everybody to participate. This is not for participation or for extra points, but this is the type of exercise in which you don't need any equation at all. Okay, you just need to observe, you need to analyze the circuit, and then you will be able, hopefully, to tell me these values. Now what happens is, if instead of working with diodes in parallel, now we work with diodes in series. That's right. So the silicon diode still has 0.7 volts across the terminals, and the germanium diode 0.3. Now the question is, what is V0? How can I get V0 without any equation? Just inside your mind.
Subtracting the voltages?
Subtracting the voltages, that's right. So I will identify the highest voltage. In this case, it is 6 volts there, and here I have -5. So because of that, I will have a current flowing from the highest voltage towards the lowest voltage, okay? This current matches the direction of the two diodes, so basically they are on. And then I just need to remember that silicon diodes has 0.7 volts activation voltage and germanium 0.3. Because of that, if I want to get this value, the only thing I need to do is 6 minus 0.7 minus 0.3. And that is going to be how much?
5.
5. Yes, piece of cake, hopefully. So I repeat, identify this voltage, going towards the direction of the current, I begin subtracting the voltages that I know. 6 minus 0.7 minus 0.3 will be 5. There's no need to write in the whole KVL equation. Now I have V0, check. Now, how can I get IDQ? If I want to get IDQ, basically, this is a single mesh, so this is IDQ. Again, BR, I have a single resistor, so BR is R times IDQ, because that's the same current. So IDQ is BR divided by R. So this is the only equation that you need to use. So now, how can I get BR?
Subtracting. Well, using sort of like KVL.
Subtracting, again, towards the direction of the current. First, this side of the resistor, what voltage do I have here?
B0.
B0, or 5 volts.
Yes, sir.
Minus, the other side of the resistor, what voltage is that?
-6.
-6, but please be extremely careful because I have this. Minus, minus. Okay? 5 minus -6 is 5 plus 6 divided by 5.6K. In other words, IDQ is going to be
1.96.
1.96
Yes, yes. Milliamps.
right? Anybody else? Yes? Okay. So again, I repeat, this is a type of exercise just for practice in which first you need to understand the problem. Please don't try to write as many equations as you can. That's not going to work, or you will run out of time. Any questions about this? Okay. The next one. You have 10 seconds to tell me what is VDSI. 1, 2, 3, 4, 5. No?
0.7?
No? 0.3.
Oh, yes,
Excellent.
yes, yes.
Why?
They're in parallel.
These two diodes are also in parallel, but just one of them is actually forward biased. Which one? The one that has the less EF voltage, and that is the germanium one. So this is actually on with 0.3, and the other one, since it is connected in parallel, is sharing the same voltage, even though it is off. Its voltage is 0.3. So very good. VDSI is 0.3. Now, how can I get IDGE? Same way. I am going to use also and only the Ohm's law. Again, VR, R times IDGE. So IDGE, R divided by R. Now, how can I get VR? Again, the current flows from the highest voltage down to the lowest voltage. Even though both voltages are positive, 20 is greater than 4, so I have a current flowing this direction. Now, what voltage do I have here? 20 volts. So 20 volts minus
4.
no. Okay.
Yes.
0.3, no. We want to get VR. That is the voltage across the resistors between this point and this point. So we already know that the voltage here is 20 volts. Now I need to tell me what voltage do we have here. 4.3. Excellent. 4.3. Why? Please know that here, I know that here I have 4 volts. Okay? Now if I move backwards, when I mean by backward is against the direction of the current, then I will recover some voltage. How much? 0.3. So here I have 4. The other side of the diode, I have, please note that these polarity marks, I will earn, or I will have 0.3 volts more than I had before. Now divided by 2.2K, and that will give us IDE
7.14
7.14
milliamps. Yeah.
milliamps. Okay. Again, all these exercises are just for practicing, just to show you that there is no real need for writing the whole KVL equation. But if you want to do that, if you feel safe by doing that, please go on. Have no problem about that. Yeah, sure. Meanwhile, any question? Anybody? Are you sure you're really quiet today?
Teacher, in this case, SI would be 0, right?
SIE equals 0, that's right. The current is 0, but the voltage is the same.
0.00. And if it's in parallel and everything, so the IDE is the current of all the circle.
That's right. Okay. May I change now the cycle? Okay. The next one is your last chance to participate, but there is a rule for that. So I need you to work at least in couples or in groups. I can only give you 2 of you. I can give you a participation points, 5 points, but both of you should come here at the same time. Okay, so you want to participate. Please choose the partner. Start working on this. Come to the front, and if you are right, then both of you will get the 5 extra points.
Teacher, and if we already have a participation?
I cannot give you more than 5 points. Okay? It's just at least not for this exam. Maybe for the last one, you can participate again for the final exam. What if you want to work with this? Or you want to?
Milliamps. ¿Me lo podría checar, por favor? Ok, bien.
Punto 21, sí, está bien. Puede ser que por algunos decimales no estos, pero se aparecen mucho.
¿Pero si estoy bien?
Sí. O sea, acaso por decimales, pero sí está bien.
Entonces, ¿sí puedo participar por lo del siguiente examen?
No. O sea, va a venir para el siguiente examen. En su momento. Sí.
Es que no traigo compañeros, claro.
No, pero todo más, aunque tuvieras, ya no puedes participar. O sea, puedes participar después del midterm, pero acá no.
Está.
Pero en ese sentido se da even though participations are already taken, what I saw is that most of you were doing it right. So it's perfectly okay, and I mean it's up to you, because of course you can perform the typical mesh analysis like this, and that's correct, okay? So you will be able to get the answer. However, my suggestion again is try to redraw the circuit. How? First of all, let's locate the highest voltage. What is the highest voltage? 10 volts. So I'm going to place that voltage at the top. And now I'm going to go down. First, I find this diode. It is the D1 diode, silicon diode. And then I have something like this. I have a second diode. This is going to be D2. And then by doing this, I will realize that actually R1 and D2 are placed in parallel. Okay? And now what? Then here I have another resistor, and then finally I have reached the ground. So this circuit is exactly equivalent to that circuit. Now it's up to you. Again, it is not mandatory to redraw the circuit like this. Just another option if you want like to have choices. Okay, so now what? 3.3K, 5.6K, and the corrects. Where is ID1? ID1 is this. I1. This is I1. This one is ID2. Okay, and this one is I2. Okay. Even though it's perfectly fine to solve the circuit with the mesh analysis, maybe all of you got the same result by using the mesh analysis. This is another option. Why is this convenient? Why? Well, because first of all, I can get really fast I1. How can I get I1? Since the resistor is connected in parallel to to D2, sorry. What is the voltage here? 0.7, okay? So I1 is basically 0.7 volts divided by 3.3K, okay? Isn't it? Again, this I can replace this with a voltage source. This it is 0.7 in parallel with 3.3, and because of that, the voltage here is 0.7 divided by 3.3, and now I1 is
0.21.
0.21 milliamps. So this is I1. Then I need to get ID2, but since I don't have an internal resistor, then the only way to calculate this is by either getting this one or this one. But guess what? This one and this one are exactly the same. Because here the current divides into two parts, but then at the other side of this branch, of these two branches, then will join again. Okay? So this current ID2 is equal to ID1. And in this case, please know that I can do this 10 minus 0.7 minus 0.7, and I get this value. Okay? 10 minus 1.4, 8.6. So 8.6 volts divided by 5.6K. And this is going to be ID1 or I2. I repeat, 10 minus 0.7 minus 0.7. Now I have 8.6 divided by 5.6K. How much is this?
3.82.
3.8.
No. Es que yo tomé 20 volts y no 10, entonces para mí eran 18, pero...
That's why I told you that you were like a little bit...
Pero ahorita lo saco.
Yes.
1.53 miliamps. Sí, ¿no? 8.6 sobre 5.6.
Milliamps or inamps?
Okay.
Mili.
Sorry, my fault. Because this is not 10 volts. Okay? Yes. It is 20. My mistake. Okay, it is 20. Okay? So, I mean, this is correct because it is true that here I have 0.7 volts, but now this is not correct. Now, this is how much. Instead of being 20 volts, it is 18.6, right? Yes. So now 18.6 divided by 5.6K?
3.32.
3.32 milliamps, okay? Some of you got 3.80 something, okay? So you got quite close, but the correct answer is 3.32. And now what? This is node A, this is node B. So for instance, for node B, I have ID2 current plus I1 current, and this is equal to I2. I have already I1, I have also I2, so I can solve for ID2. So ID2 is going to be I2 minus I1. And that is 3.32 minus 0.21. This is going to be 3.0 something. Point
11.
0.1?
3.11.
Oh, 11. 3.11 milliamps. Okay? And that's it. Now, I am just showing you an option, another methodology. Now you choose the one that is better for you, or that you think that's better for you. Okay? This is an option, but this is only an option because you all know how to do this. Okay. Any final question about this? Now, the next exercise, should I give you some extra time for copying or for processing this information? Yes? Okay. Because the next problem is a dream problem. What is a dream problem? It is a problem that you can expect to solve in the midterm exam. Yes. Sí, porque la asistencia quiere entendido para estar acá. Pues no, porque en realidad la resistencia no tiene por qué Okay, guys. This one, try to solve it individually. Okay? This is exactly what you can expect in the midterm exam. Okay? It is not so difficult, but it is not easy. Okay, so it's like in the middle. But if you don't pay attention, or if you don't understand these concepts, maybe you will struggle. So I'll give you up to 7 minutes. Try to solve keep it at your own, and then we'll discuss it. Oh, by the way, the author of this problem tells us that you should take BF to be 0.6 volts. So instead of using 0.7, please consider BF 0.6 for each time.
So look at this one, right? I1 minus I2. So again, this dash here, right? Menos 0.6 más 0.6. This guy goes. Menos 0.5. Los dos son iguales, ¿verdad? 0.6 de BF. Gracias. It's gonna be Oh, man. Profe, tengo una pregunta. Ya saqué aquí lo que es ID1 y ID2, puro KVL, pero ahora para B0, el B0 no es el mismo que el voltaje de este, ¿verdad?
No.
Entonces dije, bueno, voy a medir de este nodo a este nodo, pero esto me va a dar 0. ¿Sí es 0?
Sí.
¿Es 0?
Sí.
¡Oh!
Sí, justo por eso uso este problema, porque ¿quién dice que no puede hacerse?
Es que, pues está raro, pero pues sí. No. Qué extraños son los circuitos.
Yo no revisé el problema.
Genial. Puro que miedo.
Should I give you 2 more minutes? Yes. Okay, I'm going to show you how to redraw the circuit, just in case that you want to do that. Now the question is what is the largest and the highest voltage? Here. 5. So I'm going to place 5 volts on the top, then going down, then I found this resistor, this is 5K, and then I'm going to name this node A, just to keep track, to trace node A. Then what happens, then I have a diode like this. Let's say that this is D1 and this one is D2. So D1, the other side of D1 is connected to. The other side of D1 is connected to what?
5 volts and ground.
5 volts? To ground. Please note that this is D1. So the anode is connected to node A and the cathode is connected to ground. Okay. Now I have another diode like this, and this is D2. Now here I have V0, then a resistor, and this resistor is 10K. And what should I connect this side to?
5 volts.
5 volts or minus 5 volts?
Minus, yes.
Here is minus 5 volts. Why is it minus 5 volts? Because the negative side of the voltage source is the one that's connected to the resistor, and the positive side is connected to ground, and that is why this is minus 5 volts. Now let's say that this is node B. Again, this is just an option. You decide which one you like most, okay? So now, for instance, I am going to draw all the currents like this, this, and this. So this is I5K, this is ID1, and this is ID2, okay? Actually, I need ID1, ID2, and V0. Okay, again, what do you think? I am going to consider, or I'm going to assume that all the diodes are actually on, okay? So all of them are actually forward biased, okay? That's our first assumption. Now, if that happens, then I can replace each one of them with the simplified equivalent, like this. Now, this simplified equivalent will be 0.6, since the problem is telling us to use 0.6 volts. Now, what happens if I ask you what is the voltage here, reference to ground? What is VA? VA matches exactly the voltage inside of the diode, isn't it? So VA is going to be 0.6 volts. So again, if I have a multimeter with me and I measure from this point to this point, then I will measure the internal voltage. So now I have 0.6. Now, if I analyze this second branch, okay, from going from point A to point B, do I lose voltage or do I recover voltage?
Lose.
I lose voltage. How much?
0.6.
0.6. So since this voltage is 0.6 and then I lose 0.6, now the BB node, what's going to be the voltage there? So in other words, V0 is going to be 0. And this is where, I don't know why, but most of you start like to worry about, or maybe you get to, you will even get panic about this because you say, cannot be 0. And the question is, why cannot be 0?
It is too strange.
It's strange, but as long as you get any voltage that is in between 5 volts and minus 5 volts, that's perfectly okay. Now, if you get 6 volts, positive 6, then you should start worrying about it. Or if you get minus 7, for instance, then that's also a mistake. Why? Because you cannot have a voltage that is greater than 5 or lower than minus 5. So if you really want to know if you are correct, 0 is a voltage that's perfectly in between these two voltages. 6 or minus 7 are not possible voltages. Okay? So yes, V0 is 0. Now that we understand that, let's get ID1 and ID2. So ID1, I cannot get ID1 right now because I need to know I5K and ID2. So let's find first I5K. So I5K is 5 volts minus what? 0.6 divided by 5K. Why minus 0.6? Because VA is 0.6. So So one side of the resistor minus the other side divided by the resistor, 5 minus 0.6 divided by 5K. And then ID2 is the same as I10K in this case. So BB is 0, minus the other side of the resistor is minus 5. So we get this, and then 10K. How much is that, and how this, and how much is that?
ID2 is 0.5 milliamps.
0.5 milliamps, 0.88.
That's right.
Okay. This is another way of getting the same results. If you chose to use the traditional method, it is up to you. But yeah, I think that we have finished this one. Now, in the remaining time, I will show you why I'm not really sure that the traditional method, like this one, and the personal mesh analysis, for me, I think it's not the best option, but maybe for you, yes, it is. Now, what happens, and the next problem actually is the same topology, but now we have swapped these two resistors. See? So now instead of 5K, now I am using 10K, and instead of 10K, I am using 5K. Except for that, the circuit is exactly the same. So please go on. You already have your own equations, so try to solve it.
What is BF?
What is?
The BF.
Oh, BF is exactly the same,
Okay.
0.6. So the only difference is I have swapped the resistors. So other than that, everything is the same.
Me confundo, profe, con ese layout.
Conviértelo en el otro. Es el mismo circuito. Elige el que tú quieres.
¿Es el mismo circuito?
Es el mismo. Fíjate, o sea, yo lo convertí en este. Puedes usar este mismo, pero nada más invierto estas dos resistencias. Negative value of 91. Okay. Yeah, that's right. And what happens if it is negative? It's open. That's right. Cannot go the other way, because diodes basically avoid that. So the solution is that diode is okay. But guess what? You need to recalculate the rest of the lines. Okay, so hopefully you'll find the same equations except for these two values. Now this is 10K and this is 5K. This is 10K, this is 5K. Now can you please update these values?
0.44.
This one? 0.44
Amperes. And the other one.
amperes? Milliamperes, okay. This one? 1 milliampere.
B0 again is 0, right?
B0 again is 0. Now, I think that we didn't finish the previous exercise because we didn't get ID1, right? So ID1 was
38.
38 milliamps, right? Now, with these new values, can you please give me the new value for ID1? Minus 0.66. Okay. I mean,
I think it's 56.
56. Okay, 56. Thank you. Okay, now, what's going on? We got a negative current. Okay. What happened when you got a negative current according to the previous courses? Then that current will go or will flow exactly in the opposite side or the opposite direction, okay? But guess what? Diodes are used to avoid it. So I cannot have a current flowing, in this case, upward. That's not possible because the diode was not meant to work like that, okay? So then what happens if I get a negative current?
Absolute value?
No. Whenever you get a negative current, the meaning of that is that that diode is actually off. And you need to erase it. So I repeat, you need to be extremely careful about your values, your operations, because if you get a negative result, then the meaning, if you are correct in all your procedure, the meaning is that this diode is actually off, because I cannot have a current flowing upward.
You got a negative for one of the diodes.
And then, what's next? I need to recalculate the rest of the values. Why? Because this current is no longer valid, and actually this current and this current will be now the same. Okay, so this first approach of the circuit helped me to find which diode was actually reverse biased, and the diode that was reverse biased was the one. The one is not there anymore, okay? So we need to recalculate, and because of that, now the answer is, if this is the 1 and this is the 2, ID1 is 0. It is not negative, it is 0. Okay, so we need to recalculate, and then ID2 is going to be equal to I10K. Basically, you will be able to get that current without any problem, right? So what is the new value for ID2? Could be 10 divided 10 minus 0.6, that's 9.4 divided by 15K. So, did you get 0.62? 0.62 milliamps. Okay? So it's 10 minus 0.6. Okay. Yes. So now it is 0.62 milliamps. Now what is the zero? Can it be 0? Now it cannot be 0 anymore because since this diode is off, you cannot say that here we have 0.6 minus 0.6, 0. Now this value is no longer 0.6. So you need to recalculate the 0. How can you do that? 5 minus 10k times 0.62 or minus 5 plus 5k times 0.62 milliamps. In this case, 5,000 minus 1.8. 86. So those are in values. So why is this considered to be a real problem? Because depending on the placement of the resistors, you can get a diode to be open thanks to a negative current. Okay guys, so please go to sleep, enjoy your weekend.